Hi students, today's experiment is flip-flop. Flip-flop is nothing but 1-bit data storage device. So we have several number of flip-flops. In that first category is SR flip-flop. So SR is nothing but it is a clocked SR flip-flop. S stands for set condition, R stands for reset condition. Okay, so let us see the basic symbol. So logic symbol, logic circuit and truth table of flip-flop. Here you can see the trainer gate. So in the trainer gate it contains SR flip-flop or RSL flip-flop, clocked RS flip-flop. So with the help of circuit diagram connections, we have to verify the truth table values of entire SR flip-flop. Let us see the connections. So this one is input slot section and this one is output slot section. So as per diagram, give the connections. S and R are the inputs. S, R, inputs at the input slot section. Next, here clock also one of the additional input. Okay, so it is a default input connected to the clock generator. So this one is automatic clock generator, this one is manual clock generator. So whenever it is connected to the clock generator, it continuously produces clock pulses. That is nothing but, so clock equal to 1, always clock equal to 1. So Q and Q bar are the complementary outputs. Q bar. Okay, now. So these are the complementary outputs. Okay, now. So complementary. So these are the circuit diagram connections of SR flip-flop, clocked SR flip. Now switch on the trainer gate. So switch on that trainer gate. So when we are switch on the trainer gate, so this one is clock pulse. So whenever clock is connected, always clock equal to 1. So in the truth table, we can take the values now, always clock equal to 1. If your required clock equal to 0, you can connect here clock equal to 0. So if you're changing the data 1 0 0 1 1 0, nothing but it presents no change values. No change is nothing but, so output will not be changed. The mode of operation is called as hold condition. So always clock equal to 1, then flip-flop starts working. Now flip-flop starts working. Clock equal to 1. So clock equal to 1, S equal to 0, R equal to 0. Output also maintains no change condition. Nothing but Q equal to 0, Q bar equal to 0. And the mode of operation is called as hold condition. Next, whenever clock equal to 1, it is connected clock equal to 1. So clock generator pulses. So S equal to 0, R equal to 1. S equal to 0, R equal to 1. So something loose connection. So S equal to 0, R equal to 1. Output data becomes 0, 1. Q equal to 0, Q bar equal to 1. And this condition is called as reset condition. Next, whenever clock equal to 1, clock equal to 1, S equal to 1, R equal to 0. S equal to 1, R equal to 0. Output data Q equal to 1, Q bar equal to 0. And this condition is called as set condition. Whenever the clock equal to 1, always clock equal to 1 when it is connected to the clock generator. So clock equal to 1, S equal to 1, R equal to 1. So the output condition is called as racing condition. Racing. This condition is called as invalid. So this one for clock SR flip-flop. Right? So the next flip-flop is JK flip-flop. So in the JK flip-flop, we have to give the connections as per the circuit diagram. Here, J and K are the inputs. J, K are the inputs. Okay. J and K are the inputs. Right. So clock is given to the clock generator. Clock is applied to the clock generator. So clock is applied to the clock generator. Next, Q and Q bar are the complementary outputs. Here Q bar. So JK is designed from equivalent circuit of SR flip-flop. SR flip-flop additional ga some equivalent circuit nunchi. So S and R and input slot section lo connect chesesi 0 lo pettesi. Put it as 0. So we don't require this value. So it is directly given to the SR flip-flop. Okay na, because SR latch nunchi design chesi. So these are the values. No. Okay na. So JK values are this one. J and K, J inputs, K input, clock input, and Q and Q bar are the complementary outputs. Let us take the values. Whenever you have connected clock signal, always clock equal to 1. So now switch on the trainer gate, clock equal to 1. Output data maintains no change operation. If I required here, clock equal to 0, 0 1, 1 0, 1 1. So output data maintains also previous state operation. So if I require clock equal to 1 means, So we have to kept here clock generator. This clock generator produces continuous clock pulses. Next, whenever clock equal to 1, j equal to 0, k equal to 0. Clock equal to 1, j equal to 0, k. Output also at no change condition. No change condition is called as mode of operation, called old condition. Next one, clock equal to 1, j equal to 0, k equal to 1. So clock equal to 1, j equal to 0, k equal. Output data maintains 0 1. So q equal to 0, q bar equal to 1. The output is reset condition. Clock equal to 1, j equal to 1, k equal to 0. J equal to 1 and k equal to 0. This condition, output data maintains q equal to 1, q bar equal to 0. So q equal to 1, q bar equal to. So this one is called as set condition in the JK flip-flop. Next, so clock equal to 1, j equal to 1, k equal to 1. So j equal to 1, k equal to 1 is nothing but output is continuously toggling from 1 to 0 and 0 to 1. Okay, now output is continuously toggling from 1 to 0 and 0 to 1. You can see here output is continuously changing from 1 to 0 and 0 to 1. And this condition is called as toggle condition in the flip-flops. So next flip-flop is T flip-flop in the, so flip-flops, different types of flip-flop. T is nothing but toggle flip-flop. So it contains single input and single output. Single input is T, single output is Q. Q bar is the complementary output. Clock is the default input. So let us see the circuit diagram connections. T is connected to the input slot section and clock is given to the clock generator. So clock generator. Next, Q and Q bar are the outputs. Q is given to the output slot section. Q bar is given to the output. These are complementary outputs. Complementary means always 1 0 and 0 1 opposite values are presented. Okay, right. So these are the connection. Clock, T input and Q bar. Now switch on the trainer gate. So when we are switch on, always ikkada connect is the clock equal to always equal to 1. Okay, so మనం 0 values మనకు అవసరం లేదు. Clock equal to 1. So input data 0, output data may be 0 1 or 1 0, and the mode of operation is called as hold condition. Whenever clock equal to 1, input data also 1. So output is continuously changing from 1 to 0 and 0 to 1. And this condition is called as toggle condition in the T flip-flops. The next flip-flop is D flip-flop. D stands for delay flip-flop. So D flip-flop simply transfers input data to the output. Okay. So give the connections as per the circuit diagram. D is single input and clock is given to the clock generator. Q and Q bar are the outputs. These are the connections. Now verify the truth table. So whenever clock is connected here, always clock pulse is equal to 1. So clock equal to 1. Now switch on the trainer gate. Clock equal to 1. Input data 0. Clock equal to 1. Input data 0. Output also 0. Complementary output is 1. Okay. So whenever clock equal to 1, input data 1. So output data also 1. Simply transfers input data to the output in T flip-flops. That's it. There are 4 types of flip-flops.